There we go. Welcome to Quarkus Insight number 46, where it's the meeting of the Aarons. So we have Aaron, and we have Aaron, and then George and me sitting down.
Hey.
Who are not Aaron?
Yeah, we're not Aaron. So anyway, our topic today is Quarkus and AWS Amazon Lambda containers. But just before, we have a few news. First off is I'm experimenting with snow notes this time. Snow note? Show notes, that's what they're called. I'll put the link in here, which everyone should be able to edit, and we'll see if people are... I can throw people out if they stop being nasty, but you should be able to put things in here you want to share. And so yeah, that's an experiment. We'll see how it goes. Anyone who hasn't been here before, if you ask questions, just put them in the chat, and we will try and do them. And otherwise, the big news, or we covered it last week, but it actually happened, is that the Quarkus 2.0 alpha is out. And I think we have a few more planned before we do the GA. And the two big things that came in, well, three. One is that we dropped Java 8 support. Which we haven't... At last, yeah. And I'm repeating here again and again because I saw a few people were surprised about it, even though we've been saying it. Well, we feel like we've been saying it a few times. But yeah, so Java 11
we were actually warning when you were doing the build since at least 6 months ago.
Yeah, right. So anyway, it's there now, and even for like support, like native image has always been Java 11. Like, well, you could do Java 8, but we definitely recommended it. So anyway, that's the big thing, and we added, or mainly Stuart added continuous testing, which is this new feature that's in the build last week, where as soon as you stop at dev mode, if you have tests, you can enable it, and it will run in the background. So every edit you do, it's not just done like live without any thing. You'll also see if there's been test failing, or you can add tests and you can see if it passes, which I think is an awesome feature.
For anybody that's ever played with JavaScript web writing, when you're used to Mocha, for example, that runs tests in the background, that's
like that kind of thing, right?
I actually really like the way he did that with some of the interactive controls that he has, where you can turn them on and turn them on. It's actually more than what you have with Mocha.
Oh, it's way more because now it also tracks the association between the application code and the test. So if you change something in the application code, it only runs the tests that are directly affected by it.
which is cool. But I just mean for people who have played with Mocha before, like there's some interactive stuff with how you can control it that's a little different than that. Yeah, and I kind of like it.
I mean, and the dev UI is in this one too. I haven't actually checked it. Yeah, it should be. So even there's the console that does it in. You can also in dev UI you can see the test running, and I'm sure we'll find a way to get it into an IDE. But that was actually the one question I saw people on Twitter and stuff saying, "Hey, I wanted this in an IDE." I'm like, I've done IDEs for 10, 15 years, and there's one thing I know is that people don't use all the features that are in their IDE.
Well, just use it in the terminal window in your IDE. Done.
Sure. But that's what my point is, that the fact that it's just always there makes it something people use. Whereas if it was hitting some IDE, you have to have plugin installed or set something up.
Well, I think I haven't used it in a long time, but I used to be addicted to the way JUnit results and stuff were shown in the IDE.
Oh yeah, no, but that's
feels like a long time ago though. I feel like a dinosaur.
So anyway, it's there, and we actually started planning our insights more now, like 5-6 weeks out, so we can. And there's a link in the show notes on where to see them. But to remind people, next week is about Keycloak for those who are into that.
Oh, cool.
And we'll see. And Keycloak actually they move from, they're still on EAP and Wildfly, but they moved to a Keycloak based one, so now they can start up in, I'm not sure it's milliseconds, but at least like low number seconds.
One, you mean?
That's super. That's super.
Because that was the biggest critique of Keycloak was it was a bit. Oh, I'm not saying the biggest, but one of the biggest. That it was very hard to. It took minutes for it to start up probably, and now it's in much faster.
Super cool.
Oh, and Sebastian, who is the guest? Is that next week? Yes, it is.
Oh no!
I have a count.
Oh man, have I totally been there? Oh no! Is that tomorrow?
So anyway, I hope Sebastian is aware.
It's now.
He says in my calendar. Anyway, so let's get back to Aaron, or the left Aaron. Aaron, who are you and how do you get involved in this?
I guess I've kind of been working in kind of the Java space for a long time, annoying the likes of Max and Emmanuel and Gavin back in the day, in the early JBoss days, and even pre-JBoss days. I worked a lot in Hibernate and
all the way back there.
Sort of have been kind of involved in this space on and off since then, but more recently. So the company I work for is a company called Base2 Services, and we kind of specialize in AWS really, and we work with development teams all over the world, and we work on application modernization. We work on automation at an infrastructure level, but also at an application level as well, around CI/CD and all of those fun things. But my role is I really work with development teams on the sort of development process, and also looking at like modernization of applications. So I'm, I guess, fortunate enough, I'd say fortunate probably, to see all sorts of applications in all sorts of states, some dating back to the early 2000s, still using, EJB2 technology in 2021, which is a scary thought.
Wait, did you say you're doing EJB2 in now?
We have, in production, we look after EJB.
Wow. Sorry to hear that. But, but fortunate enough, as I said. And so I guess I put myself in a very fortunate position to work across lots of different technology stacks and frameworks. And so I also like to dabble in frameworks and technology. And so whenever like I heard about Quarkus, I was saying Quarkus before, so I was corrected earlier. So Quarkus. When I first saw it, I went, I thought sort of put it on my. It was in a browser tab for about 6 months probably, to look at. And then one day I saw a tweet or something from, I think it was probably from Max or someone. And I decided to actually do something about it, and so that's when I started playing around with it, and went, oh shit, oh shit,
oh shit. I was like, that was literally what I said. I was like, oh shit, this is freaking cool, right?
Oh, it's a good shit. Okay, good.
Oh yeah. I was
like that was a tweet that happened last week, where there's somebody, I forget who it was. They said the first time you see the Grand Canyon, that's what you say. Oh shit.
Yeah. So that was my reaction. It was like, oh wow, this is like different, right? This is not a rethinking of an existing framework, or this is a totally different approach, right? And so that to me was the most interesting about Quarkus, is that it just flips the problem, and no one had really done that in any significant way. And so for me, that was like, okay, cool. I need to do this. And because, I work a lot with AWS, and so we, and a lot with containers and a lot with Lambda, right? So we work with a lot of customers that are, 100% serverless stacks on AWS. And so, and some of them are, come from sort of traditional Java backgrounds, right? So their core stack is Java, and they're comfortable working with containers. They're comfortable with deploying, Spring, even things like JBoss Fuse and stuff. We have quite a few customers that deploy that in containers on AWS, right? And but they want to kind of move into the serverless space, and there's a lot of friction with writing serverless applications in Java, right? You can do it and it works, and it's not a terrible experience, but it's much better when there's something that kind of supports that. And so that was kind of for me, like, okay, so when I saw Quarkus and I saw that there was native Lambda integration, I went, okay, this is really cool, right? This changes the story of, can I run a Java application, that a JAX-RS, application, the canonical Quarkus app, right? Which is so simple. You look at the code and go, what's going on here? Why does it work? And run that in Lambda, right? And run that in Lambda, but not have the experience suck, basically, right? And so that was really cool. And then, but it was still the story around packaging and deployment, and this is the story for Lambda in general, right? It's kind of terrible. Zipping up code and sending a zip file to S3 and registering your function is a pretty terrible experience, right? From a user's perspective. And this is the case for all languages on AWS. It's not just Java, Node, packaging up dependencies. And it partially got solved a year ago with a thing called Lambda Layers. And so Lambda Layers is a way of like creating a reusable block of code, in Lambda, where you can share that layer between Lambda functions. So you can have a base Lambda layer that, you install all your dependencies and you kind of manage that, and then you're just deploying your code on top of that. And that solved a lot of problems. But really the penny really dropped for me when at reInvent last year, 2020, they announced native container support for Lambda. All right, so the ability to create Lambda functions using a container image, right? So you can basically now create a Lambda function and basically point it at an image. And what's really cool about that is that then kind of means that there are a lot of limitations in Lambda, how much code, like code sizes and things like that. That sort of, if for a Java app could be with lots of dependencies, could be a problem, right? Packaging up a very, a reasonable size Java app. And so the ability to kind of just, hide all your, and this is what I love about containers, hide your laundry inside the container and package it away nicely into a nice clean interface, and then deploy that, right, to Lambda. But not only that, it meant that the development experience was consistent, right? So that not only when you were developing your Lambda function, and there are plenty of tools that kind of make that experience a bit nicer, but at the end of the day, like just being able to run a container locally that behaves basically the same as it behaves when you deploy it to Lambda, and that's some of the stuff I'll in the demo I kind of go through. So after that announcement, I kind of went and started playing around with it, and I wrote a blog post which will be in the show notes. But basically, if you can see my screen, that's
two things.
That's basically this blog post here. And basically what I'll do is I'll go through the demo, and I'll kind of explain as I go. But if there are questions, please interrupt me as we go, and I can kind of talk about different pieces of it.
I have one very important one. Where's your t-shirt? Where's your t-shirt from?
Well, my t-shirt is from. Can anyone see my multicolored ball?
There we go. That's like a 2005 thing.
Did I drop off?
Yeah, you just gone for a few seconds.
Oh, good. As I was mentioning about my multicolored balls, I was showing my multicolored balls.
Oh dear.
It's a factual.
It's an inside joke. I hope somebody on the live stream will get it. So I know Max will. That's probably Max is probably the only person.
The rest of us just have really bad juvenile sense of humor.
Exactly.
It was an actual event.
It was.
Well,
So
anyway.
I have a JBoss T-shirt going back to 2005. So I just thought I'd wear it for nostalgic purposes. On the live stream. So so I wrote a blog post, but I'll go through go through it. But basically, what I did is I took a standard Quarkus archetype, which was the Lambda AWS one. By the way, it's an old version. I'll update it one day. You guys are probably at like version 100 by now, right? So the speed that you guys want at.
113, but I think this hasn't changed.
I'll go to 2. Yeah, I'll have to try 2 alpha to see how this behaves. And so I generated a standard Lambda archetype app. Basically, what you end up with is the sort of classic. You don't need to see the Hotwire one. Basically, a standard Lambda example, right? For you get the test Lambda, which basically implements the runtime interface for Lambda, and uses CDI to inject a dummy service, and then basically handles the request. And in this case, it's pending some context about it, and we'll see what that why we're kind of adding the AWS request ID to the context, just to kind of give you some visual feedback of that is being invoked.
So just to be clear, so because we had Bill on a week or two ago about Funky. Yep. This is using the raw.
This is using the raw, yeah. I had an attempt at a Funky one, but the container support for that is something that is still there'll be there's some rough edges, right? And I think there's some integration work that needs to happen to kind of make that smooth. And I'd be definitely keen to kind of an area where I have quite a bit of experience and keen to kind of help out in that space.
I'm sure Bill would like to have PRs, pull requests.
Yeah. And so this is there's nothing about this that's container that's container specific. This is just a standard one. You would can deploy it, package it up as the zip file and deploy it using the standard Quarkus steps, right, to do that. So to basically deploy it in a container, there's a couple of things that you have to do. One of the things that you have to do is that to the POM file, the AWS have launched what they've done is that they've created this AWS runtime client interface, and basically what that does is that's basically emulating the Lambda runtime, right? In software, this is the runtime that you can expect to interact with when you deploy your function in AWS. But they give you the library that you can interact with that locally, right? So you can package that inside your container. So what I needed to do was basically include that dependency, right, in my container, like in the libraries that get packaged up, right? Okay. So that's the only additional thing from a Java dependency that we needed to kind of add to make that work, right? So that's that. So basically, add that dependency to the thing, basically, and then basically I can just kind of I can package this code as normal, right? So at this point in time, I've done nothing specifically container related. I can run I could run dev mode if I wanted to as well, and go and make changes to the code, and the code would run in the normal dev mode. Which is not in a container, all right? So that would just be the normal developer experience that Quarkus provides for Lambda, right? So in dev mode. So then what we need to do is actually create a Docker file. One thing you'll need to remember to do if you are working with Lambda, this is that you'll need to kind of tell Quarkus which handler to invoke. And so I'm invoking the test handler, which matches the name of the handler that we annotated, right? So that's just something that you need to remember if you're creating a different one. And then you can kind of package up your Lambda function as, and if you notice, that one was using Java 8, which is obviously now deprecated. So, but what's happening is Lambda, AWS actually provide base containers for their Lambda runtime. So every Lambda language that's supported now supports, Amazon now publish base containers for Lambda. And so you can basically leverage these containers, and they have all of the required setup for it to work in Lambda. You can go and create your own Lambda container from any distribution, from any base container that you want. But then you have to kind of do the various steps like configuring the Lambda runtime client, right? Whereas this one provides, and there's a link in the blog to how to do that, like for a full container. So you can kind of do that. So basically, there's a Docker file that basically sets up and this one uses Java 11. In the blog post, I never updated it. But basically, what we do is we just copy the compiled Java app. In this case, I'm not using a native binary. But just using the Java runtime, right? So I'm not compiling it to a native binary. The experience would be different if we were doing that for a native binary, and we wouldn't necessarily be taking advantage of some of the advantages of using the Java runtime in using the sort of Lambda runtime Java client interface, right?
So we actually we have a few questions before we
go
too far.
Yep.
So one is just Jonathan asking for in the plan support Apache CouchDB, which is not really related here, but I'll just say that we don't have specific support for it. I haven't even seen it mentioned that much, but I do know that you can use CouchDB as a normal client, Java in JVM mode, and that works.
Mm-hmm. Yep.
Native mode, I don't know if there's a limitation, but I also know Apache has their Quarkus Apache. What's that called? Quarkus Apache Camel Apache CouchDB extension. So it does exist in Java mode, but I don't know the status of native mode. Georgius or Aaron, do you know?
I don't, but I'm thinking that's a Quarkiverse thing if anything's necessary.
Yeah.
I could pull it up. I mean, I have old. Well, I mean, in my case, it was CloudInt, but I have some old stuff around.
So yeah.
But I used to use it all the time. So
if anyone wants to do it, we have the Quarkus, but right now it's not something we have on our direct radar. But it's very usable today. Oh, sorry, it's possible to use CouchDB with Quarkus. We just don't know the native status of it. And then there was one more here, and I'm not sure. So Andrea says, "Are any plans on making the handle property a compile time property and use it to optimize the build?" I'm surprised it's not a compile time. It seems to be a very static one. We should have Bill probably the one who could answer that one. But yeah, it sounds like something that could be. If it's not, I suggest Andreas, you open an issue for it. It seems to be possible, but that's something for Bill to comment on. Okay.
Yeah.
And then Goran just says he wants it too. So.
Right. I mean, the one advantage of not doing that is that then it's possible to do things at runtime.
Yeah, you could flip it during deployments, but it's
correct.
Yeah.
Correct. That's the only thing is that like I have used that to change certain behavior.
Yeah, that's the thing, right?
That was just on my side. But yeah, basically, basically when we build the container, we're kind of building it as if we were uploading the zip file, right? What Lambda does is when it unpacks your code, it puts it in a specific location, and then and then basically runs it. So basically all we're doing inside the Docker container is basically emulating that, right? So that we're emulating the capability of, we're copying the jar, the runner into, the lib directory, and we're copying any dependencies. And then, we're telling the Lambda runtime what our handler is, right?
Yeah.
And so from there, basically what we can do is we can kind of build that container, right? So we can run a Docker build on that Docker file, and we can simply just package it up as a container, right? And the other thing we can do, obviously, is just run that. And so what happens is when we run that container, and Gitpod stops annoying me, we're basically now at the point where our code's running and it's waiting to be invoked. So it's waiting. This handler is now waiting to handle invocation. And so what we can do is we can actually invoke that, and we can invoke that with just curl, for example. Somewhere I have a curl statement. There we go. So I'm invoking this Lambda function, and I'm invoking it, and it's behaving like Lambda, right? So it's expecting this function invocation path, and to invoke the function, and I'm giving it, some input, and then I invoke that function, and then I get the response back, right? And we can see that there's a request ID, but this is all being emulated, right? The client runtime environment is emulating the Lambda runtime. Okay. That as if it was running in Lambda, right? So normally what you'd have done in the past is you might have created a slightly different entry point into your application, and you would have just had it accept HTTP or something like that. And then you would have called the same business logic. But now you can just run it locally and have it accept the native Lambda support. So it's behaving as if it was deployed to AWS Lambda, which is one of the sort of nice sort of the powers of kind of running it this way.
That's cool.
And the other advantage of that is that I have a container, right? So now I can push that container, right? I can let me what you would do is you would create let me show you it. You would create an ECR repository, right? So I would create this ECR repository in Amazon ECR. So that's the container registry. As you can see, I just logged in. There's the create image container. I'll just copy it out from somewhere else. Here it is. And so it's telling me that it already exists because I already created it, because I didn't want the demo gods to fail me and have my credentials expire or something like that. So I already have this image basically created in ECR. And so this is basically the repository where the container is going to live. And then from there, I can push my image, right? So I can just do a Docker tag because I created that image. I can create it. I've got some, and I can. One of the limitations right now is that, the container that you push has to be in the same AWS account and the same region that you want to deploy the Lambda function to. So that's kind of the current limitation. That is something that AWS themselves are working on to support cross-region, cross-account deployment of Lambda containers. And so that's kind of a bizarre limitation, which will hopefully go away. But basically, right now I'm tagging the image, and then I can basically just push that. Just push that to already logged in to ECR. So, and let's push my container. And one of the nice things about leveraging this base layer is that obviously I don't care how big this is, and because it's optimized and on the Lambda side, right? So I only care about how big my app is, because one of the advantages of me relying on an Amazon layer is that they would have this is highly optimized for deployment inside Lambda. In other words, they have it cached hot caches running inside the Lambda infrastructure to pull all of these images, right? So all of the images that they maintain. So there's an advantage to kind of relying on the AWS space layers. There's lots of optimization that they're doing inside Lambda's infrastructure to make that experience, like to make that super fast. So I've now got my container in AWS. Now I want to deploy a Lambda function that references that, right? So in this case, what I've got is a SAM template. So AWS SAM is basically stands for Serverless Application Model, but basically what it is a deployment framework for serverless applications. It's based on Cloud Formation, and means I can declaratively define my function. And previously, like this might look familiar if you've done Quarkus, the Lambda. If you played with the Lambda integration, this would look kind of familiar, but the primary difference is the package type, right? So this is what AWS added support for. So previously that package type would have been, zip or something like that, and then you would have had like a URL to a zip file. But now the package type is image, and I'm just making it convenient by passing that image, the reference of that image as a parameter to this stack, rather than hard coding the image here. And so now what I can do is I can deploy this template. And so let me just grab the deployment function. So that's basically this function here. So let me just do that again. So basically all I'm doing is calling a standard AWS CLI Cloud Formation deploy, referencing the stack name, referencing the template, that's this template, and then the URL, that parameter that I was going to set, which is basically pointing to my container. So I can run that. And then that's going to basically start running. And if I switch over to the console, you should be able to see that the template I've just created is currently being reviewed in progress because it's creating a change set. This is all AWS Cloud Formation stuff. Yep. So it's now creating it. So we can go in here and we can look at the events to see that it's creating my Lambda function. It's creating an IAM role because Lambda functions require a role to execute against. So it's going to create those resources. So it's created that. Next, it'll create the function. So this is creating the function itself. I can show you resource types. You can see that this is a type Lambda function, and that shouldn't take very long. And then.
So, and this what you apply now is a JVM mode Quarkus, right?
Correct. JVM, correct. JVM mode. Yeah, correct.
But if you want to do that, that'll be easy for you. Just change it in the image and then
correct.
Off we go. Yeah.
Yep. So the image is here. So this is the function that got deployed. You can see that it's referencing the image that it's referencing. That's the one that I pushed. So you can see here that the image is one of the things. If I really want to, I can just deploy a new image from the console itself. If I feel so inclined. Yeah. The other thing we can do is we can test it from within the console as well. So I can go back to get my sample request that I can just do. Let me just grab that. So let me grab the payload, and I can go to here and I can paste it in. And one thing, this is something interesting that you'll notice. So you can see that this is taking a bit of time. And this is one of the challenges so it took 3.6 seconds. And that was, what was happening was that this container was being pulled for the first time into the Lambda infrastructure. Because at this point in time, even though I deployed it, it hadn't done any optimization because it didn't know I was ever going to invoke it. But now when I rerun the test, you'll see like it's executing in milliseconds, right? So it's now called that function. We can see the outcome of it, right? It's called that function in less than a millisecond. Like we're being billed for a total of 2 milliseconds. So it's basically bootstrapped, run Quarkus, and exited in that time, right? So you're getting the execution time is very fast. That first pull into the environment is usually happens when you basically deploy a new image, that very first request. It's not even the cold start time, right? This is different to the cold start time. It's pure code initialization. Yeah, exactly. Yeah. It's pure code initialization. So it's not like if this Lambda function goes to sleep, you'll have that same hit. In most cases, you won't see that hit again for this version. And that I've tested it over days too, so you'll see some advantages. You'll see this will be for a cold start time. It's sort of 15, 20, 30 milliseconds, as opposed to like 1 or 2, right? So there's a noticeable difference, but it's not like absurd.
And how does it behave differently when it's a native image?
Yeah, so if you're running a native image with a container, this is worse. Because it is that way because you're pulling more layers.
Right.
Right.
It's you have a lot less cached.
Correct. You're having to pull
unique image.
Exactly. It's a unique image. It's not optimized, right, for that. It's basically a unique image, and because the native containers still have to have the runtime interface as part of how it gets invoked, right? How Lambda talks to that. And when you have a native image, you have to package that. If you're doing it as a container, you have to package all of that runtime up in your image. And so there's some overhead to doing that. And so that's sort of where the optimization of doing it and relying on those base images, you get some advantages to that. There's some performance optimizations to doing that. Right.
Do they have I wonder if they have a scratch image.
They don't.
Right. That would be the question, is if they ever got
Correct.
a scratch image. Because then you still have the layer and you just add the binary on top.
Correct. If you could do, there's still you'd have to have the scratch. It would be basically a native layer, right? So where you can call a native executable. There's no base layer for that. But there are the layers that they depend on. And so there's some there's some advantages to doing you can solve some of that.
Well, so I don't know what's in this base layer, but if that one is able to run like a Java thing, you should all be able to run a native static compile.
Let me, if I can, I had the link is, so this is a link to creating Lambda images. So this is kind of the blog post. Let me make it a bit bigger. It might be a bit too small. And so there's some of the requirements for it. And if I go down, it's probably easier just to show you the Docker file for it. Is that basically, this is a Python example, but basically applicable to other things, in that you're installing your dependencies, you're installing the Lambda runtime dependency, and then which is this here. So in this case, it's a Python library. There's an equivalent, obviously there's that Java one the Java library that would need to be included. And then they're doing a multi-layer build. So they're then kind of building that in and copying those dependencies in. And then they're setting the entry point, and that's what's actually doing it. So this is what's calling it. So you could do the same thing, but for a native image, right? And so then that would be able to handle that. So there's sort of the equivalence of that. But then there's the overhead of pulling those layers, right? Pulling this base Python layer. So there's a small overhead to doing that. But again, the overheads are once it's kind of pulled that into the infrastructure, if it's pulling it into a new instantiation of that function, it's a lot faster because it's got a cache inside Lambda, right? Basically, they run a mirror registry, and the infrastructure is sort of optimized for that. But you do notice those you can notice those performance difference. And I've been experimenting with different ways and different container models to kind of to try and find what that sweet spot is for that, to try and make, and also to understand it, because like obviously, with Amazon, it's a lot of this is a black box, and so it's only through iterating over different setups to kind of see which one has different properties, right? So it might be if this if you're updating the Lambda function frequently, you might do something different to something that you might optimize for cold start, right? And so that there are certain ways to kind of, might take different approaches for different types of things. So if you were, changing your code very frequently, you would want to optimize for the initial invoke of that code, as opposed to something that you don't update that often, but you want to update it you want to invoke it infrequently enough that you could be seeing cold executions, right?
So Goran Opatish, I think, sorry if I mispronounced your name. He says there's a cast that AWS Drive Container keeps Docker layers closed machine with executes. I think that's what you refer to.
Yep, exactly. Yep.
And he says it refers to cast whenever you deploy a new Lambda, even before the first execution. Well, I guess in this case you didn't. You ran the execution before that triggered.
Correct.
Yeah.
Correct.
So
that will happen at a random period of time. It won't happen on deployment, because otherwise it holds up to deployment. And you can see that behavior if you deploy through the console. If you update the function in here, you can see that behavior.
But if what Goran says is the way it works, you should be able to just deploy and then wait some amount.
Yep.
And then when you run it again, you have a not a 3-5 second thing, but maybe like a double millisecond thing.
Yeah, it can be. I've seen it vary depending on I've seen the execution vary from tens of milliseconds to hundreds of milliseconds.
Cool.
So
are you using this in production or?
We've switched a lot of. So how we sort of manage a lot of infrastructure and automation for customers, and so we have switched and we deploy a lot of Lambda code. Lambda is one of those. It's like glue code, right? So we deploy a lot of sort of automation pieces and tools to sort of automate, AWS environments and deploying standardized monitoring and tooling and that kind of stuff. And so we've switched we switched pretty much all of that, or in the process of switching it to container-based deployment from sort of packaging up zip files. One of the things that we're really waiting for is the support for cross-region, cross-account deployment, because then that means we can build the container once, push it to an authoritative ECR repository, and then just allow permissions for those other accounts to pull that, so that we can centrally manage it. Right now, we're then having to kind of replicate that image out to, hundreds of AWS accounts.
Yeah.
Hundreds. Yeah.
So what will be your let me rephrase that one. So what are some good use cases for the Lambda, or rather, what are some bad use cases? If you want to cover that.
Yep. So my view is that I think the container deployment model for Lambda will become the sort of pseudo de facto way to deploy to Lambda. I think that is, when Lambda was created, containers were a thing, but not really like a packaging, not really as well defined as a packaging thing, right? As a packaging mechanism. And so I think now is probably the right time for that to be the case for Lambda, and that I think that we'll see standardization moving towards making that even easier than what it is. And I think that will be, I think that's just, I think, the way from what I see Amazon going, right? I think that's just, an obvious step in that direction. In terms of the use cases, basically, if you're going to be deploying anything to Lambda, then you should probably consider packaging it as an image. That's kind of my feel. But
what use cases do you use? Well, so the use case I think was for Lambda, like.
Yeah, sure. Okay, so Lambda in general, right? So really there's when Lambda on its own is okay. Like it's a compute environment that you can, you'll build by the millisecond, which is nice. It's a scale to zero problem, so it can scale to zero, and it can scale to very large numbers of executions without, with you just paying money.
Super bursty traffic is a use case. Super
unpredictable burst, right? So bursty traffic, if you know when the bursts are coming, you can probably optimize a sort of, a normal container-based environment to kind of handle that in potentially a equally or cost-effective way. But I think in terms of where you have absolutely no idea when those scaling events could occur, and there are plenty of use cases that work. Like ad tech is like a lot of ad tech is moving to serverless just because they have no idea which ads will get traffic and which ones don't.
Well, one that hits a bit more home is, for example, our GitHub bot. We talked with
exactly.
Which is reacting to events, and then
Great.
Yep. Yeah. So like the classic is okay. Anything that's kind of event based, right? So, and my view is that like I come from a middleware, ESB, sort of that kind of space, and to me, Lambda is like and Lambda plus other AWS services equals enterprise service bus. That I know it's a fairly controversial thing to say, but to me, that's how I see it, right? Like it's just a service bus, right? It's just a way to execute code, to respond to events. It's a way to receive requests and do something with them. It's like a fairly generic thing. Where the challenges come is to do that in a way that doesn't end up in a mess. And that was the same with
what writing. I always found, I wrote some stuff in functions. Well, actually, I was using OpenWhisk, which is what I found is that you really had to change how you were thinking about, because you have to break it into event pieces. So what's coming in and what's going out is very different than your usual REST flow, because you're just in the middle of some chunk.
Yeah.
I don't know. I found it very challenging to switch to work in a function place, because you really are just one. Like it's like you're thinking about a data pipeline kind of thing, where you're one link in the chain, and then you go to the next one and the next one.
Yeah, and I think that's where frameworks like Quarkus can help, because I think a lot of those frameworks are taking the request response model pattern and applying sort of a convention to make it fit a sort of event-based environment, where you can write an application that looks like a normal JAX-RS app, but have it deployed to Lambda and behave that way. And if you're using integrations with like API Gateway in AWS, if you're deploying it, so say if you in this context, if we're talking about AWS, if you deploy it to AWS, that includes the construct is deploy it as API Gateway plus Lambda function, and then you get the same experience, right? So that from a end user app perspective, I just wrote a JAX-RS, a handler that accepted my post and did what it needed to do, and then returned a response. And that's really, I have another demo, but it's not ready to show, where I'm kind of experimenting with Lambda and using Hotwire. I don't know if you guys know about Hotwire. It's server-side rendering of HTML.
The
DHH.
Yeah, DHH.
Okay.
HTML over something. I forgot what it's called.
Yeah. So
new demo.
Yes, exactly. So I've been working on a Quarkus Hotwire example, where you deploy that to Lambda, right? So that basically the sort of app kind of sits, it's basically serving up HTML over the wire, and that is what to me felt like a relatively it's in the early stages of me basically making it work, but it felt like a reasonably complete kind of solution, right? To kind of handle what would be traditionally done with a sort of static Angular JS kind of front end and API back end. And deploying it to Lambda just seemed like a logical kind of extension to doing that.
Yeah, so that gets into partial pre-rendering, right?
Correct.
Which most of them are doing now.
Yeah.
They've changed.
That's server-side render UI.
Yeah.
Right. That's right.
Yeah.
Well, it's just everything just goes in circles, right? Then in a few years again, it'll be all client side.
Yeah.
It works.
Yeah, they started. So it used to be the whole single-page application stuff to avoid re-rendering, but it's been 5 years now. It feels like of a move back to at least server-side rendering of partials.
Yeah.
Not quite portlet, but definitely okay, I'm going to give you back the ginormous list of movies, but they're going to be pre-rendered so that the browser isn't redoing all those pieces or something.
Yeah. Yeah. So cool. that to me, I think was there are a lot of, we're working with a lot of customers that have a serverless first approach. In other words, that anything that they're going to be developing, they're going to consider using a serverless base. And I mean, Lambda is only one piece of the serverless story, right? It's not the only piece. It's like the raw compute part of it. There are plenty of other things and other considerations to when you are looking at kind of serverless in general, right? So
yeah. So I would say that's if we were going to generalize the why. Most people would be doing serverless first because they're trying to avoid the problems that we have had where you have to pre-allocate a bunch of infrastructure when you don't know which endpoints are actually going to get traffic or be used.
Right.
So you create all these endpoints for your APIs for pick your favorite phone app so that they only are in use while in use and they're otherwise completely quiet and not costing money.
Correct.
That's cool.
Yeah.
Okay. Anything else from you, Aaron?
No.
All good. So next time you'll come and talk about Quarkus with Hotwire.
Yeah, that would be. I kind of was, because I'm an old school Java guy. Server-side rendering.
Stop saying it like that's a bad thing. I think all of us are in that bucket, so it's not a bad thing.
No. JSF was like that was a thing. I was that was my thing. Yeah.
So we got a question from
That
Goran.
was definitely not my thing. I hated it.
I hated it. We all hated it, but
it's better than what we have now. Well, sorry.
Yeah.
I didn't say that out loud, but I was. No. By the way, just before we take Goran's, it's funny because I've seen a few times recently we got people asking about how to use Quarkus with front end development, and we actually there's a blog now showing how to do it with React, and we actually have one from last year or even 2 years ago about Angular, because it's fairly simple, and but the only thing you have to do is you have to start your own the front end service, the front end npm first, and then you take the Quarkus and it's there. So yeah, so anyway, there's interest. So if people have it, they're there. But the Hotwire thing would be fun because it's a little bit different. So it's good.
Yeah, and that I was using the Qt template extension with Quarkus. So that was kind of my okay. So how can I do some old school server side rendering?
Yeah,
but do it in a way that doesn't isn't server side rendering.
Yeah. So Goran here says, "Can Quarkus tree shake product code if I use the handler test?" So this was coming back to the early question about the settings.
Build time, yeah.
So right now it can't at runtime, because it's a runtime property. If I understand correctly, if it's a build time one, it won't shake it in Java mode. But technically, I guess when you're running native mode, it should be able to tree shake it. So then it's GraalVM shaking that code out. And whereas in Java mode, it will just not be loaded. That'll be the only thing.
Yeah, and the issue with the native, doing Java, doing native mode is you need to then provide the Lambda runtime dependencies yourself in the container, right? So if you're going down to point to point, deploying it in a container image, if you're just deploying the layer, the native layer, then you're deploying that to an AWS is kind of providing that.
Yeah. So
if you're just providing the native binary as part of your package.
Yeah. So it's only going
to do that.
It's only going to be an issue if your serverless code base is so big that it's bigger than what a native image will be. But it won't be, right? It's going to be fairly simple, and yeah.
You would think that, Max. You would think that. But I've seen some Node zip Lambda zip, that push the boundaries of the package limit in AWS, and they went to containers to get around that limit themselves.
Yeah.
So you can't assume that.
That's true. But so anyway, to answer the question, yes, it technically is, but right now I don't think it is. If it's a runtime field, then it's not going to tree shake it in any form.
No.
So yeah. Okay.
It would be interesting. It's like you'd have to opt into that mode, almost.
Yeah.
You have to say, I want this one to be a build time thing. It's like we would want a build time version of the property, and if you define that, it would would do the build time thing, and if you did it as the runtime thing, then it would do the runtime thing.
Yeah, exactly.
Yeah, it's if you also wanted to create like this comes down to if you want to create a container per function, or whether you want to create a container image that contains multiple functions that all the functions, and your Lambda config, your handle config is what decides what function to call, right? So there's some advantages to doing packaging all your functions in one container and then kind of deploying that way, as opposed to having 100 container images, right, for your 100 functions. Yeah. And so Lambda Layers goes to try and address some of that by you can package up all your dependencies into that one layer and then have that reference. So.
And I see Goran here is saying, when we compile to native, will it know that some code is not used? Yes, that is a feature of GraalVM. So what for those who don't, what Quarkus does is it has a build time phase, which besides meaning we do stuff at build time, so we don't have to do it every time we start up. For example, parse the Hibernate configuration, or what's another good example? REST-EC has to wire up its annotations, that kind of thing. It does it at build time, so it doesn't have to do that every time, so it gets faster to start up. But it also makes it so that we actually can detect which parts of the framework that people are using. So we get everything statically initialized. But the great thing is that it also makes it very good for GraalVM to go and do, what is it called? Dead code path analysis. Yes. So, and that's where literally they go in and analyze the bytecode and see which call branches are used. And if it's not used, then just don't deal with it. And if you see the compile phase, it's actually one of those that takes the longest. But the end result is you get a much smaller binary.
It can take forever, but it's because it's looking under all the rocks to see if you're using something or not. But so Andreas has the comment after this, right, about whether or not it's a runtime property. So that's why I'm saying we would have to do something that would recommend the build time property so that Graal could do that. So I think the question in Goram's, like, the piece is what is it? Which piece is it that would know? Right. So in the case where we put something with a build time property, then we would help set things up such that Graal could know. But if it remains a runtime property, then it would all be there.
Yeah, exactly. Right. So a classic, yes, it can't know now, but a classic one, for example, the DB kind we have, right, is a build time property. So we always, if you set your database as Postgres.
Yeah, but what just came up recently? Can we have that be a runtime property, please?
Oh yeah, well we knew all this stuff would come up.
Yeah, I know.
So, but it's a balance, right? So
yeah, exactly.
I think in that case, if we wanted to do it, it would have to be an opt-in kind of thing.
No, what we say is correct. That's just it. Done.
No.
No, I'm just kidding.
But it's funny.
We've changed obviously various times from build time to runtime.
Yeah.
But the problem is, for example, if it becomes one, like there's large chunks of Hibernate that you literally have to then bundle in. For no good reason,
exactly.
right?
Yeah, that's the balance that you would need to pick, like what can and cannot be changed, because this doesn't only affect GraalVM, it also affects JVM mode, right? Because the JIT compiler, the more hard coding you do, the more stuff it knows to optimize.
Yeah, no, it's one of those things, like when you compare, like what is the thing that makes Quarkus different? So besides, like, we like, make developer productive, we not want to be native, but it flips things around, like the build time. Stuff happens at build time, and we care about these small things.
Mm-hmm.
And those are the ones that makes us, be at the top of the performance evaluations that are done out there. Because we literally...
In the case of Lambda, that also means you don't have the, like, traditionally we would say eventually your JIT will optimize things to be super fast. But in Lambda, you don't want to wait for the JIT stage to happen. You want immediate right there. So when you do this stuff at build time, you're getting to the place where that optimization happens out of the gate because it's been done already.
But I was saying,
you're not relying on JIT warm up.
What I hadn't really thought about before until Aaron said it was that there is advantages in having everything in one big image on serverless. Right? So you can just configure it, because then you have things move around, it's cast and that kind of thing. Yeah. But that's the thing, is there's so many different ways of doing it. And the good thing is Quarkus can do almost all of them. So
that's the key, right? You want to have the 90% use case just there and work, but you want to still leave the gate open for where you can do it differently and for a good reason, right? And it might be that that's a complete edge case, but it's super important.
Man, I love that you go for 90-10 instead of 80-20. That's awesome.
I think that you should have less things. See, the problem with 80 is you're left to way too much open, right? I still like 90 is like it's like most, it's like there's only that one person, and it's usually me. I'm usually the annoying.
Just that one guy.
Just ask Emmanuel how annoying I can be.
Yeah, we know. Okay. Anyway, we are past the hour here, and thanks to Aaron for coming and talking about this, and thanks for the questions we got.
Yeah.
And I won't be there next week. But next week, hopefully, with Sebastian agrees that he is actually talking about Keycloak on Monday. I think
he said he was ready. He remembered. He's on.
Come on, he could do it with his eyes closed.
Yeah. And I think we also got Stian, he's a committer on Keycloak, who's going to talk about all the horrors he had to go through to make Keycloak a Quarkus app. I think he's happy, but it's big change to make.
It can be interesting anytime you do that stuff, because you figure out all the stuff that people did that you forgot why.
Yeah.
It's great. It's so great when you go back, like, why did we do that? Oh my God. There's always the best nightmare stories. Yeah. It's awesome.
Yeah. Quarkus is good to turning rocks. Figuring out what's
Very.
Okay, guys and girl.
All right.
See you around.
Thank you.
Bye-bye.
Have fun. Bye-bye.
Thanks.